in this course, it's important that you minimally know the basics of Angular. This means understanding Angular modules, components, templates, services, and routing. If you don't have the requisite knowledge, consider taking one of the introductory Angular courses first, such as Angular Getting Started or Angular First Look. You do not need extensive component communication experience. We'll cover what you need in this course. Another great way to get the most from this course is to join the discussion. Thoughts, comments, or questions as you watch this course? Feel free to use the discussion tab. You can find the link to the discussion on the Pluralsight page for this course. Or follow me on Twitter. It would be great to hear about your experiences with component communication. There is also a blog post specifically for this course at the URL shown here. This post identifies common issues along with their solutions. If you have problems with the code for the course, check here first. There may already be a solution provided. As with most software development, there are multiple ways to accomplish the same objective, and we'll cover many different techniques in this course. So, how do you know which to use when? That's when some good guidelines can help. I'll present guidelines at the end of each module. We'll use them as a brief review of the techniques presented in that module, and as a set of suggestions for which technique to use when, as you build your own applications. Coding along through the demos is another great way to get the most from this course. Though not required, it is often helpful to try out the presented techniques. I've set up a public GitHub repository specifically for this course. It is called Angular Communication, and you can find it at this URL. The starter files for the sample application are here. You can use these files as a starting point if you want to code along with the demos. The final files are here, but note that in many cases we achieve the same goal using multiple techniques, and these final files only show the last technique we used. If you're new to GitHub, simply click this button to download all of this code as a zip file. Because this is a course on component communication, I've created the majority of the components and templates as part of the starter files. The hands-on activities then focus on communication techniques. So what is this sample application? Let's take a look. We'll be working with a sample application throughout this course. Let's see the starter files for that application in action. Welcome to Acme Product Management. As its name implies, this application manages our company's current list of products. You may remember this application from such courses as Angular Getting Started and Angular Routing. The root app component contains only a router outlet. That way we can route pages, such as our login page, to this router outlet and not display any title or navigation bar. Note that the login does not check your credentials, so you can enter any values here to log in. We then have a shell component that provides the application shell. It has a title, a navigation bar, and another router outlet where the router places the main views, such as the product list page. On the product list page, there's a button to hide and show the product images. And here is a filter by box to enter a value to filter the list. But the page does not currently filter. We need to communicate the user's entry to the component so the component can filter its list. We'll do that shortly, trying out several different techniques. Clicking on a product name navigates to the product detail page. Clicking on the edit button navigates to the product edit page. Here we can edit or delete a product. If there is a validation error, a validation message appears and the Save button is disabled. If we try to navigate away, a route guard asks for confirmation. This helps prevent the user from leaving the page accidentally and losing their changes. The Add Product option takes us to the Edit page to add a new product. That's the basic operation of the sample application that we'll use throughout this course. We'll also examine an alternative layout for this user interface that displays the product list and product detail concurrently, and look at ways for these components to communicate. Now let's finish up this introductory module with a look at the outline for the remainder of this course. In this course, we start with the basics and look at how a component communicates with its template. We cover binding and getters and setters. Next, we examine how to get a hold of an element in a template and work with it directly using viewChild or viewChildren. We review the special relationship between a parent-child component and look at how a parent component communicates with its child and how the child component communicates with its parent. Then we shift gears and look at how a component can communicate with itself or with other components using a service as an intermediary. Next, we examine how to build a more complex service to retrieve, manage, and store our application state, and how to send notifications between components using subject and behavior subject. Lastly, we look at how to pass data between routed components using the router. Let's get the communication started. Every component has a template, and to display data or interact with the user, the component needs to communicate with that template. Welcome back to Angular Component Communication from Pluralsight. My name is Deborah Kurata, and in this module, we examine several techniques for communicating between a component and its template. Our component's first attempts at communication were most likely with its associated template. Early on, we learned how to use binding to pass information to and receive events from the template, and how to use structural directives to control which elements appear within the template. Here again is our component communication diagram from the prior module. Our focus in this module is on communication between a component and basic elements in its template, such as the input element shown here. In this module, we start with a quick review of binding and structural directives. Then we cover other ways of communicating between a component and input elements on its template, including two-way binding, the long way, and the very powerful but underutilized getters and setters. We'll look at more advanced techniques, including the viewChild decorator, in the next module. Now, let's get started. Binding is often the first technique we learn for communicating between an Angular component and its template, so it's assumed that you know how to use basic binding. Let's do a quick review just to ensure we are all on the same page with regard to the terminology. We use interpolation to display the value of a component property in the template. Property binding allows us to bind a component property to an element property in the template, such as the style width property of the image element. We use event binding to catch user actions in the view and notify the component by calling one of its methods. Here we catch the click event and call the toggle image method in the component. Two-way binding keeps the value of an input element and it notify the component by calling one of its methods. Here we catch notify the component by calling one of its methods. Here we catch the click event and call the toggle image method in the component. Two-way binding keeps the value of an input element and its bound component property in sync. Another common way for a component to communicate with its template is through structural directives. We can leverage structural directives to affect the elements that appear in the view. Use ngIf to include or exclude elements from the view. In this example, when showImage is true, the defined image appears. When the component sets showImage to false, the image is removed from the view. Use ngFor to repeat an element in the view for each element defined in an array declared in the component. In this example, the table row element is repeated for each product in the array of products. As products are added or removed from the array in the component, the view displays the updated list. In preparation for trying out more complex techniques, let's take a quick look at the code of this sample application. I am in Visual Studio Code with the APM sample project open. If you are coding along, these are the starter files you downloaded using the link provided in the previous module. To use these starter files, you must first install the required packages. Open the VS Code integrated terminal and type npm install. This installs all of the packages defined in the package.json file. I've already done this step, so I won't do it again. Let's focus for a moment on the product list component. I'll start by running it so we can review how this particular view works. In the terminal, type npm start. The welcome page appears, and we click Product List to view the list of products. At the top is our page title. Here we have an input element for entry of a filter by value, but trying it out, it doesn't currently filter our products. We'll look at how to fix that shortly. This table contains a row for each of our products. The button here hides and shows the product images. This column of the table contains a nested child component that knows how to take a number and display it as stars. Now let's check out the code. I'll close the terminal, then open the product list component and its associated template beside it, and close the Explorer for more space. We use interpolation to display the page title. The input element uses two-way binding to display any default filter value and to keep the list filter property in the component class in sync with any user-entered value. Here is our table. Notice the ngIf here. Whenever we use binding in a template, we need to watch out for null or undefined values. Using the ngIf ensures we don't try to display the products until the products array contains data. We could instead write this expression using the safe navigation operator, defined with a question mark. The safe navigation operator returns null if the value is null or undefined, and does not continue evaluating the expression. In this example, when the page is first displayed, products is undefined, and this won't attempt to return the length. When the data is retrieved and the product's property is populated, then it returns its length. It only navigates to the length property to evaluate it, if it is safe to do so. The button in the table header uses event binding to execute the toggle image method each time the user clicks the button. This flips the flag defining whether or not to display the product images. In the body of the table, we use the ng4 directive to display a row for each product. We are actually binding to the list of filtered products, so we'll see the filtered list once we get the filtering working. The image element has an ngIf directive specifying whether or not to include the product image in the view, and it uses property binding to set the source of the image, its title, and some of its styles. We use interpolation and some pipes for the other table data elements. And here is our nested child component. It knows how to take a number and display the appropriate number of stars. We'll talk about communication between a component and its child component later in this course. So binding and structural directives are a very powerful and useful mechanism. You'll find that in many cases, the best way to communicate between a component and its template is by leveraging binding and structural directives. But what if you need something more? Here we have a method to filter our products based on a passed-in filter value. But how does the template tell the component to execute that method when the user changes the filter by value? When we use two-way binding, we define a property in our component class that the template uses for the binding. If that property has an initial value, our component provides that value to the template as a default value for display. If the user then changes that value, our component property is automatically modified to match. To perform some operation each time the value is modified, like actually filtering the list of products, or recalculating a total when the user updates a quantity in a shopping cart application, we need a way for the template to communicate each change to the component so the component can perform the desired operation. There are several techniques available to achieve this requirement. In the template, we can use an updated version of two-way binding, the long way, or in the component class, we can specify a getter and setter, or we can leverage the Angular forms directives and use the value changes observable, even when the input element is not on a form, like in our example filter by element. Let's try the first one first. The two-way binding syntax is actually a combination of property binding and event binding, so we could change this shortcut syntax to its long form, like this. We bind the ng model directive using property binding to the component's list filter property. This one-way binding from the component to the template ensures that any default value defined in the component is set in the input element. And we use event binding to catch any user-entered changes to the input element. When we catch the user's change, we update the list filter property and the component with that change as defined by $event. $event holds the payload, or contents, of the emitted event. In this case, the ng model change event tracks the value changes, so $event is that changed value. With this syntax, we still have our two-way binding, just in its long format. But this doesn't help us much. Our component property is changed, but our component is not notified of that change. So we still don't have a way to perform an operation in our component each time the value changes. Now that we have explicit event binding, however, we can change the event handler to call a method in our component and pass in the changed value with $event. When the user changes the input element value, the ng model change event is emitted, which calls the onFilter change method in the component, passing in the modified value with $event. We then have a component method we can use to perform any additional operation we need. Note, however, that we really don't have two-way binding anymore at this point. Though we are leveraging the long format for binding, we are no longer setting the list filter property when the ng model change event occurs. So with this code as it is here, the list filter property will not be set to the user-entered value. We'll have to handle that ourselves in our onFilter change method. Let's try this out in our demo application. Looking again at the code, in the product list component template, let's change the basic two-way binding syntax to a modified version of the long format using the ng model and ng model change directives. We use property binding to bind the ng model directive to the component's list filter property. This sets any default value from the component. We then use event binding to bind the ng model change event, but instead of setting the list filter property as we would in the two-way binding long format, we'll call a method in the component class. I'll name that method onFilterChange, and we'll pass $event to that method to provide the changed value. Next, we write the code for that method in the component class. In the template, we called the method onFilterChange and passed in the current input element value, which is a string. So that is the method we create here in the component class. This method won't return anything, so we set its return type to void. In the method, we first set our local property to the passed-in value. We need this because the template is no longer using two-way binding to set this value for us. We then perform any other operations we need. In this example, we call the performFilter method to filter the products based on the current value of the list filter property. Let's see if it works. Bringing up the browser, we type in a filter value, and the product list is filtered. Yay! But looking back at the template, this code the browser, we type in a filter value, and the product list is filtered. Yay! But looking back at the template, this code looks a bit foreign, especially for other developers that are used to seeing normal two-way binding. Is there an alternative way to achieve our goal? Yes, there is. Like other languages, such as Java and C#, TypeScript provides two ways to define a property. The most common way to define a property is to simply declare a variable and optionally define its type or default value. You've probably used this technique throughout your component classes. But there is another way. You can instead define two functions. one that is executed when the property value is requested, called a getter, and one that is executed when the property value is set, called a setter. The setter passes in the value to be set and does not specify a return type. Note that when using the property getter and setter syntax, there is no backing variable automatically defined to actually hold the value, so you need another, often private variable to retain that value. The pattern for getters and setters then looks like this. We define a backing variable to hold the actual value, specifying the data type as appropriate for the property. This variable is private and therefore encapsulated within the component class. It should only be accessed using the getter or setter. Code in the getter returns the value of the backing variable. The getter is called anytime the template needs the value for binding. Code in the setter sets the backing variable using the passed-in value. If the template uses two-way binding to bind to this property, every time the value is changed by the user, the template communicates that change to the component by calling this setter. Hey, that sure sounds like what we need. Notification each time the value is changed. Because these are methods, we can add any code we want. We could add code to the getter to execute every time the value is requested, to pre-process or format data, for example. Or more importantly for our scenario, add code to the setter to execute every time a bound value is modified. Using a getter and setter is often a great design pattern. Let's try it out. We are back in our APM application. Let's start by undoing the code we changed in the last demo, so we can try filtering our list of products using the getter and setter technique instead. In the components template, change the filter by input element back to the shortcut syntax for two-way binding, the syntax that most Angular developers are more used to seeing. In the component class, we'll delete the onFilter change method, since it is no longer called from the template. Checking out the result in the browser, as expected, we see that the filtering no longer works. Now let's instead notify the component of changes using getters and setters in our component class. First, we need to delete the current list filter property. We can't define a property both with the declaration and a getter and setter. We can only have one or the other. I'll paste the code following the getter and setter pattern from the slides. We define a private backing variable to hold the actual value and set its type to a string, since our filter criteria is a string. We use an underscore before the variable name to indicate that it is a private variable and should not be accessed except through the getter and setter. Here is the getter function that takes no parameters and has a return type of string. This function simply returns the value of our backing variable. Here is the setter function that takes in the value for the property. This function sets our backing variable to the passed-in value. It is here that we want to filter our list of products by calling our performFilter method, passing in the value of the list filter property. Bringing up the browser, we type in a filter value, and the product list is filtered. Yay! Looking back at the code, using a getter and setter is a clean, clear, and easy way to communicate user changes to the component. Every time the user modifies the input element, the two-way binding calls the setter and notifies the component of that change. So we've seen two ways for the template to communicate value changes to the component class: modifying the long form of two-way binding in the template, or using a getter and setter, primarily the setter, in the component class. Both techniques notify the component of users' changes in the template. Which technique you and your team choose depends on your style guidelines and preferences. Personally, I often use the getter and setter approach, since I tend to favor logic in the component over details in the template. But what about this last option, using the value changes observable? Before we can examine that approach, we need to look at another type of communication between a component and its template, leveraging the viewChild and viewChildren decorators. We'll cover that in the next module. For now, let's finish up this module with some guidelines for using the communication mechanisms we just covered.